Yeah, I can press record and record myself. Anything you want to say?
I love you, whoever's listening to this.
Alright, it's recording. Okay. I can do it actually, it'll just be a big file.
Did we get our tests back?
The tests I'm grading right now, so they'll be back later.
You gotta start over.
No, I don't.
Yep.
We're going live, man. Just roll with it.
YouTube.
Okay, so I have two equations here. With these two equations, the problem I have right now is that they're not in order. So if you're going to solve systems with elimination, you want to get them back in the correct order. So the first one is fine. So that first one I can leave as it is, x minus 3y equals 4. But the second one I want to change because I want to have x's and y's on the other side. So of course what I'm going to do is to both sides add y, and to both sides add 2x. Since they're both subtraction, I'll just do the opposite. So I'm going to rewrite that second equation as 2x plus y equals 1. So now that becomes my system. Same system, now I can use elimination, and it's done pretty simply. I can do two things here. I can multiply the top equation by negative 2, or the bottom one by positive 3. I'm going to do the first option here. So times negative 2 to everything here. So this rewrites to be negative 2x plus 6y equals negative 8. We're going to hear a lot of sneezing in this video. So these first two can just use elimination on these right here. So you have 7y equals negative 7. Easy enough. What's y?
Negative 1.
Exactly.
Yeah, Hopi. You go, girl. Yes.
We're live. Okay.
Let's just make a radio
So to find x,
station.
it's going to be 2x. Instead of y, we're going to do minus 1. Plug in y there. So then 2x equals 2. Because of both sides, I add 1. That means that x is going to be just 1. So there's your answer. You can write it as x is 1, y is negative 1, or the actual points, 1, negative 1. Either way, it's the same thing. Either way, it's fine. That one's not so bad. Any questions on that?
No.
Perfect.
Nope. Next one. Nope.
All right. This one. I cannot multiply one equation here because I have no coefficients that are multiples of the other one, so I have to multiply both in this case. So, let's see. Kaylin, what can I multiply the equations by to make them cancel out? Which one? So the first one by 6.
And the second one by negative 4. Or that.
Okay, I agree.
Thank you.
Yes.
Can you multiply the first one by negative 1.5?
You can.
Would that be fine?
Yeah, you can do that. It's just that this one you want decimals, but you might sometimes. But if you do want to do that, it's absolutely fine. We usually avoid decimals though, but you're welcome to do that. So rewrite them both. The first one becomes 24x minus 36y equals 72. It's all multiplied by 6. The second one becomes negative 24x plus 36y equals negative 72.
No solution.
You'd think so. However, we have 0 plus 0 equals 0.
Oh my gosh.
So,
So x and y.
it's not extraneous. It's very common to say no solution, but this one, you have the equation 0 equals 0. Is that a true or a false statement?
Infinite.
That's a true statement.
That's the truth.
Pretty true.
Which means you have infinite solutions.
Oh.
Oh, Mr. Randy, you're so smart.
Whoops.
Oh, you just skipped like 4 pages.
I know. Problem is I'm
Do it again.
I'm too close to the arrow, so I just have to put the letters up here.
You're good.
Well, it's infinite solutions. I can't write anymore because that arrow's going to go to the next page. So when you have 0 equals 0, that's infinite solutions because that's a true statement. If you get 0 equals 5 or 0 equals 1, that would be no solution. So that's the difference with these two.
So it's always infinite solutions?
In this case, it is. if you have 0 equals 0. If you have 0 equals 1, that's a false statement. That's no solution. Because here, there's a whole bunch of different ways to make x and y make the equations true here, so that's why it's infinite solutions, because the whole entire line, if you graph this, would be true. Okay, next one. So let's see here. Alright, well, you're right here. How would you do this?
Hold on, I'm writing it down. You'd multiply the first one by 2.
Right.
Or,
Since 5 goes into -10,
or you can
twice.
guess and check.
take the first one by 2. You could also guess and check if you want to waste a lot of time. That's absolutely fine. That's your time, not mine. So multiplying the first one by 2, that's what you get. So now your two equations for elimination
This one's no solution.
are these two right here. And this one, Dan, you're on the right track. Because you have 0 plus 0 equals 7. So now your equation is 0 equals 7. That is an absolutely false statement, which means you have no solution. So again, 0 equals 7 or 0 equals some other number, when it's false, this is no solution. As opposed to this, which is infinite solutions. So those are often confused for each other. That's the difference.
Do people actually watch these videos?
Yeah.
Like how many?
Yes.
I get counts.
Like 2?
On YouTube?
No, like 15.
Wait, you can come? Does this go onto YouTube?
I can.
Mr. Randa, I'll just jack up your loads for your views. So you're on the news feed.
All right.
Get more views on games.
So next one. This one's a little different. I don't know if you guys see examples like this in Algebra 2. So equation 2 looks alright, but equation 1 doesn't quite look alright. We have fractions, and usually fractions are not fun to work with. So, any idea on how to get rid of those fractions on equation 1?
Multiplying by
15.
Yes.
You just don't do it.
You guess and check.
And you get a 0.
You guess and check.
You guess and you don't check. Easy as that.
You guess and don't check. Right. But yeah, you want to find the common denominator still. So 3 and 5 is 15.
So it's basically what we did last year.
Exactly. But now you supply it to systems.
Do you make people watch these videos?
Yes.
That's why you have the
It just
views?
force people to like watch this.
No.
So what I'm doing here is just making the top equation be written without fractions. Now I can work with it easier. So 15 over 3 is 5. It's 5x. Multiply the second one by 15. It's negative 15 over 5. So it's negative 3y. And then 1 times 15 is 15. 15 fifths, also known as 3. So this is your system now you can work with. So now you just solve it as usual. So any ideas on how I could use elimination here?
Multiply the top by negative 3 and the bottom by 2. Why? For the y.
So negative 3 to the top one, and the second one by 2. That should work, because you're going to get rid of the y's. Make that positive 2 there. So you got negative 9x plus 6y equals negative 3. And then that second one, you have 10x minus 6y equals 6. And now it becomes pretty simple. It's always nice when x cancels to 1x. So that goes away, and this becomes 3. So we're halfway done. X is 3. I'll just plug in the right here since it's already positive 10x. So then you have 30 instead of 10 times x. Minus 6y equals 6. Which means then that negative 6y equals negative 24. Because of both sides, I just took away 30. Which tells you that y is 4.
Whoa.
Then you go on from there. So, Hopi, again, to go back to your question, you're absolutely right. It's the same thing as before, but now we apply it to solving systems instead of one equation, we have two equations to solve. So otherwise, it's the exact same thing. So when you have just numbers, it's not so bad. Absolutely.
Do you ever get people in China watching these videos?
I feel like if you post this on YouTube, you get a lot of views because just our comments.
Do you guys want to comment on it? Go ahead.
Guess and check.
They just guess and check.
Sorry.
No, it's fine.
Okay, cool. Senior seminar is very.
Congratulations, Melanie. She passed.
So did Rachel, and you weren't celebrating.
This morning?
Yeah.
Yeah, so did everyone else that went.
I know you went this morning.
I went this morning at the same time as Mom.
Oh, well, congratulations. How's it feel to be done?
Yeah, well, did you pass?
Huge
I
weight
did pass, I
just
just-
completely lifted off my
Okay, oh my
shoulders and ran
God.
away.
The exact
Did
same
you
thing
really?
Kelsey said this morning.
What?
Did
Pretty
you really
much.
choose to go again? No, you did.
What?
The other half of you guys wait till next semester.
Did you actually choose to go again?
So wait, so
Why?
now,
Why would you choose
Rachel,
to go again?
so now next semester, are you going to laugh at the
Went to,
kids
like,
who are all
do
freaking
more,
out?
And I get out of class.
I'm gonna
Oh.
No one helped us. I want to help us.
It didn't go as as I wanted it to
Like
go.
me too. Like now I can actually decorate my tree. Like now.
And I
I'm
was just
gonna
like,
decorate my
I
tree.
was just
Our
like, I
cookies
just
drink
want to take
hot
this
cocoa
practice,
for
so I
like a
just
week
want
and
to
I
go
haven't
again.
touched it.
Like they were like,
Can I
if
move
they
on?
have the choice,
Okay.
choose to pass, or just like.
All right, next one. This one is guaranteed to be brand new for you. Because this
How
one,
can we do this?
Very creative.
You
Whoa.
can't
You
do.
times everything by XY.
well, here's the thing. Dane, it's a good idea. You could do that if you wanted to.
Or you could
So-
just times it by 3 and just cross out.
Just look in the book.
You could do this, again, find a common denominator, do it all by xy.
What section are we in?
Here's the problem, though, with that.
Or you can make Mr. Randy do it for you.
If I do this,
Mhm.
I have xy over x plus 3xy over y equals negative xy. So yeah, I mean, the x's will cancel out and the y's will cancel out. Makes it pretty nice. Problem is, I have this xy term, which completely throws off your style of solving systems. So when you have variables in your denominator, we don't do it this way. So instead, I'm going to erase it and try something else.
Okay, so we don't do it this way.
Not for these.
What section are we in?
Chapter 6. If you have numbers in your denominator, yes, you can just find a common denominator and solve.
But we're already
But
at
with this
6.
one, we have variables. I skipped ahead. We'll go back to 3 though next semester. Instead, here's what we're going to do. We're going to use a process called substitution. So what I'm going to do is I'm going to make 1 over x equal to something called u. I'm going to make 1 over y equal to v.
Why?
Well, I'll show you.
You add more letters, it makes it more confusing.
This is the devil's work.
Watch me do it.
Watch it.
Okay. So 1 over x, that's right here. That's just u. So I put a u right there. The 3 over y, that's the same thing as 3 times 1 over y. So that becomes 3v. So u plus 3v equals negative 1. That's the top equation. The bottom equation, instead of 2 over x, I'll make that 2u. Because it's 2 times 1 over x. So I'm using this right here. And then instead of minus 1 over y, that's just minus v. So I've just taken the equation. It's the same equation, just rewritten it with substitution. Now what you have in green is a lot easier to solve. So here then I can just take the equation on top, multiply this one by negative 2. So then negative 2u minus 6v equals positive 2. Combine these together. So that's nothing to use. You have negative 7v. And then you have 7. So what does that make v?
Negative 1.
Negative 1, right. So v is negative 1. And then I'll take the top equation. I'll plug in -1 into v. So 2u, it's going to be plus 1 because it's negative 1.
U is 2.
Right. So 2u equals 4. That means that u equals 2. This is kind of just like what we did before with the quartic polynomials, as far as having x to the 4 solving those equations. When you get u and v, you're not done. Now you plug it back in. So since the v is sharper at the bottom, I guess. My bad. Anyways, so v is -1. So I'm going to use this to solve for v. So 1 over y equals -1. So what that means then is that -y equals 1. I've just done what's called cross multiplication. Multiply both sides by y. That means that y is actually -1.
Okay, my question is, are you always going to use 1 over x equals... Never mind.
Are you sure?
Yeah, never mind. I used a stupid question and I figured it out.
Okay.
Oh, this is minus, not okay.
Okay, then for u. So u is 2. So 1 over x equals 2. So to solve that, just cross multiply. So 2x equals 1. That means that x is going to be 1/2.
Are these going to be on our homework?
Yes.
Oh.
So this becomes your final answer. So you get v and u, then you use v and u, go back to substitution, and get your x and y. So x becomes 1/2, y becomes -1.
Wait, I got lost.
Well, I'm going to show one more example.
What do you do after you get the v and the u?
Well, do you see right here, Wally? These rules. I plug v here and u there, and then solve for x and y by cross multiplying.
Oh, okay. Okay.
I'm going to do one more of these.
I'm going to skip all those on
There we go.
Here are my two new equations.
We're back, everyone.
So, thanks, Wally. And so, what we've got here is, again, I have variables on the bottom. So it doesn't work the same way. I'm going to use that same trick, substitution. I'm going to call 1 over x u. So, Kelsey, I'll make it a softer u. It's more obvious. And then I'm going to call 1 over y minus 1.
P.
Oh, I'll make it p, that's fine.
Or do A and B.
Okay.
Why?
Wait, right here?
You pick the hardest letters to put on here.
Just put a V. Get that out.
Sorry, people can play. I'm going to change it to a p.
Put a W.
Is
It
that
was
better?
a P.
I know, but that's a better p. Okay. Stop it. So that first equation, instead of being 3 over x,
Wait.
I'm going to make that 3u.
Wait, it looks like a smiley face with its tongue. The tongue.
It does.
Oh, God help us all. Okay.
Can you?
And then,
Can you circle
no.
that?
No. And then, instead of 9 over y minus 1, it's 9 times p.
Oh, I get it.
Does this make you feel good about your status as a Bears fan?
I'm heartbroken already.
Now you gotta read it now.
Now, are you in PE right now?
Yeah.
Okay, so you guys see that? First equation, I just rewrote it with substitution. That's all I did. Okay?
So the -1 just goes away for now?
Well, I made y minus 1. That whole entire thing is p.
I get it.
So you keep this over here for the end, when you get u and p solved.
So the denominators turn
So-
into the equal.
Would you have to write this?
Basically.
You actually need a PE reflection?
Okay, so second one. Instead of having
I can't play.
negative 5 over x, we're going to have negative 5u. And then instead of having 11 over y minus 1, it's going to be plus 11p. And that equals 3. So now they're written in a solvable form. I can solve these for u and p, plug them back in, get x and y.
So multiply the top one by 5 and the bottom one by 3.
Yeah. Take the top one by 5, take the bottom one by 3, and go from there. So I've got 15u plus 45p equals 30. And then for the bottom one, I've got negative 15u plus 33p equals 9. So keep going. You've got, wait, not 88. That was dumb.
You guys like waddled over to each other's.
78p is 39. So what does that make p?
A really bad fraction.
Hold on.
Right. This,
0.5.
also known as,
Half.
right.
Not that bad. Thank God.
So p is going to be 1/2 in this case. So I want to find u, but keep that in mind that p is going to be 1/2.
Thanks.
Costs like $1.50 on Amazon.
I had a pen that was like a real pen and then had that at the end. So the pen ran out of ink.
What I'm going to do now is I'm going to solve for u with this equation. And so negative 5u plus 11 times 1/2 will be 5.5. Which means then that negative 5u will equal, negative 2.5? Which again, divide both sides by negative 5. I'm running out of room here. This also makes u equal to 1/2.
So I have to go plug that back into it, right?
Right. So now, okay, so you solve for u and p. Now I go on from there.
All the p equals looks like he's trying to like lick his nose.
Nice.
You're welcome. It's done. It's being recorded.
I know. So now up here we've got p equals 1/2 and u equals 1/2. So we're going to solve for each one. We'll solve for u first. I'm actually going to erase that arrow there. So we've got then is 1 over x equals 1 over 2. So what does that make x?
2.
Anybody?
Wait, do you
What?
multiply
I was
the 1 to
listening.
the other side?
1/4.
No. Don't just guess.
1/56.
Danny, stop. This is cross multiply, so 2 equals x, and you're done. That's x. And then over here, since p is 1/2, 1 over y minus 1 equals 1 over 2. So again, cross multiply. So 2 equals y minus 1, which means that y equals 3. And there's your answer. So this takes a few more steps, but it's the same idea once you can use substitution.
Oh, was that the last example?
Huh?
Is that the last example?
No.
What is the longest
I don't have
one of
any
these
more rooms,
videos
so I
ever
can't do
How many
it.
more
been?
examples
So-
do we have?
A couple. So basically, the moral of the story, if you have fractional coefficients of x and y, use substitution. If you have just numbers for your denominators, then just use common denominators and go from there. Pause it. I don't have it. I'm recording now.
And
So,
we're back.
for one application, and you guys are consumer ed, most of you, so you guys have probably heard this before.
Consumer economics, not education.
We call it consumer ed at my school.
Consumer economics and Derek.
No, we're not.
Derek needs the C.
I'm glad that you guys are so concerned about that. Seriously, look complain about anything I say. Okay. Anyways, hey guys, listen up, please. Okay, so you've got supply and demand. You guys have learned about that, I assume, by now in that class, if you're in the class this semester. So for any good in the market, whether it be a commodity, whether it be a product, whether it be a service, the higher the price of that product, the more people are going to want to make it. Right? I mean, for example, if you have a babysitting job and you only get paid $8 an hour, you're not going to want to do as much if you got paid $40 an hour. You'd be more willing to work more if you got paid more money per hour. So that's the same idea with supply. So the higher the price, the more you're going to want to make. That's production. Demand's kind of the opposite, right? If you want to buy a product, well, the more it costs, the higher the price, the less amount you're going to want to buy. Think about maybe gasoline. If gas all of a sudden tomorrow is $5 a gallon, you're not going to want to buy as much. You're not going to want to drive as much. Right now it's cheaper, so you want to drive.
We're back.
There you go. Okay. So this is kind of what the supply and demand graph looks like. Have you guys seen this graph before in Consumer Ec?
Yep.
Okay, good.
Intro to business.
I did, rather pay attention to it.
Okay. So usually demand curves have a negative slope because if the price drops, right, price gets lower, people want to buy more of that same product. If you can afford more of it. If the price goes up, people want to make more of that product because they can make more money for it. So usually the supply curve is positive, and the demand curve is negative. So what this point in the middle is called is the equilibrium. It's where supply and demand are equal for price and production. So usually most businesses will do market research, they'll figure out these supply and demand curves, and they'll produce products that meet this point right here. Whatever it may be. So for this class, you guys are usually given the equations for supply and demand curves, and you just got to figure out when they're equal. So here's an example of that. So if you, and again, use your shorthand skills on this for note taking. So here's an example out of your book. So let's say you're a business that sells floor tiles. Through market research, they figured out that the demand for those floor tiles is modeled by the equation right here. P equals 6C minus 0.75x. What that basically means is that P stands for price, that's dollar amount, and then the X is how many thousands of boxes of tiles they will sell. So this is a negative slope because your M is negative 0.75. So obviously the higher the price, the less boxes will be sold because people won't be able to afford as much. And they won't want to buy as much for a higher price. So again, your demand curves are usually a negative slope like this. For the same material, the same product, the supply equation looks like this. So again, P stands for price in dollars, just whole dollars, and X stands for thousands of boxes sold. This is the positive slope because again, if you charge a higher price, people want to make more of them and sell more of them because obviously the money is higher. Price drops, people make less. Price goes up, people make more. So all they want you to do here is find the equilibrium, quantity and price. So all you really got to do is find the price and the quantity that makes both equations equal. Okay, you're looking for this point right there. Okay? Question, Blair?
No.
You sure?
Yeah.
Okay. So all we're going to do, we're going to rewrite both equations and just solve them. So the first one, P equals 60 minus 0.75x. This was the demand curve. My supply curve is right here. So the price equals 0.8x plus 5.75. So how would you solve this system? What's one good strategy to use here? Why, Jake?